and good day to all of you out there, and this is Physics Psych. Today we're gonna tackle about freefall. What is freefall, by the way? Freefall is the cause of the gravity. So the conception is that when an object is heavier, it will be lighter. And when it is on great acceleration, it will be lesser. Freefall has air resistance or friction. We can see freefall like on spacecraft, with bouncing a basketball, pitching baseball, and many more. We can have an experiment all about freefall right away. And now we're back. Before we make the experiment, who is the one who discovered freefall? Galileo Galilei. He irregardless the mass rate of falling is equal to gravity. And it is also about air resistance. And now it's time for the experimental!
So, that means we're going to have to neglect air resistance. If we drop a ball in a sheet of paper, for example, it's pretty obvious that they don't fall at the same rate. If we could remove all the air from the room, however, we would find that they fall at the same rate. And Commander David Scott actually did this on an Apollo mission to the moon, where he dropped a hammer and a feather at the same time. And you can find the video if you look it up on Google or YouTube, and you can see the hammer and feather fall at the same rate. They hit the ground at the same time. So we will analyze objects neglecting air resistance, which is really a form of friction.
Well, in my left hand I have a feather. In my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? It proves that Mr. Galileo was correct in his findings.
Now, near the surface of the Earth, objects in freefall accelerate downward at a rate of 9.81 meters per second squared toward the center of the Earth. Of course it's toward the center of the Earth, because it wouldn't make a whole lot of sense if you were walking down the sidewalk, you tripped, and you fell up into space. Everything accelerates toward the center of the Earth. This 9.81 meters per second squared is a constant that we're going to learn this year. We give it the symbol little g, and it's typically known as the acceleration due to gravity. But that's a little bit of a misnomer. Really, we should be calling this the gravitational field strength, because right now, as I hold my pen right in front of me, it's not really accelerating. The acceleration due to gravity says it's 9.81 meters per second squared. Really, it's feeling a force from gravity, even though it's not accelerating. If I were to remove my hand and it started to fall downward, however, the acceleration of the pen would be 9.81 meters per second squared. Now, g itself, this little g, we're always going to call positive. So g is 9.81 meters per second squared. But it's possible that something could have an acceleration of negative g, depending on how we set up our axis. And we'll talk about that here in a minute. Finally, one other thing to keep in mind is that it's only 9.81 meters per second squared right near the surface of the Earth. As you get further away from the Earth, further out in space, g gets smaller and smaller and smaller. And on another planet that has a different gravitational field, you could have a different value for g. So g is 9.81 meters per second squared downward, and acceleration is a vector. It has a direction toward the center of the Earth. Now, if we're talking about objects falling from rest, if we drop something, if it's falling, it starts with an initial velocity of 0. Once we let it go, it will accelerate. Its speed will increase on its way down, but its initial velocity, its VI, will be 0. Now, remember when we were setting up our kinematics problems, we said we're going to call the direction of an object's initial motion positive. So since the object starts by falling, we'll call down here the positive direction. That means the object's velocity is going to be downward. That'll be positive. And since acceleration points down, that means that our acceleration A is going to be equal to positive g, because the acceleration vector points in the same direction as what we called positive y. Let's